Okay, hello everybody. My name is Ilmari Kontulainen, and today's topic is going to be about becoming a Git power user. And let me share my screen. I hope everybody has been able to join already, and people are able to see my screen. But so basically, today's topic is going to be some typical practical Git tips and tricks that we are going to do in practice. That basically should make you more efficient as a Git user. And I'm going to go through most of the effective ones of workflows and techniques that I have found useful when I have done the development and so on. That there is a lot of more advanced stuff and kind of like fine tuning the stuff and these kind of things. But the purpose of this kind of Git power user webinar that we are now doing is more of a teach people to take kind of like the next level. So if you know the Git basics, then some of these tips and tricks will help you then to enhance your current workflows. And if you are interested in finding out more about the topics, there are of course myriads of resources around the web that you can find out different things. But yeah, without further ado, I'm Ilmari from Deveo, and today's topics are as follows. So we'll start off with like very pretty basic stuff. Then building up to more complex stuff and more advanced topics. So basically, first we're going to go through different types of Git aliases. So these kind of things that when you're working on, especially on the command line, and all of the examples, by the way, we are showing today are in the command line. So even though there are great graphical user interface tools that help your progress and help you to kind of like figure out some things. I believe in this kind of becoming a power user in some tool. You should know the tool, and especially the tool and nothing built on top of that, because then that's just an extra layer of complexity and layer of things. So we are going to stick with the basics, doing the exercises on the command line and see how they go. But okay, so if we go first to the Git aliases, after that we talk a little bit about rewriting the history in various ways, then a little bit about fast context switching and when you need to do fast fixes or something like that. Then about different merging strategies, undoing different things, and lastly how you find out if you have screwed up something, or you think that your commits are lost, for example. Okay. So the first topic, the Git aliases. So I have listed here a couple of like basic Git aliases I use, or what I have found useful, and how basically we are going to then go them through by example. So basically, first of all, like when you're working on the command line with Git, and you're often typing like the basic commands like git checkout or git commit or git log or git diff or whatever. So basically, after a while, that comes pretty tedious. So what the aliases do in most simplicity, they allow you to write those things more quicklier. So instead of, for example, writing git checkout all the time, you could write git co. So by defining a new alias. And how we define aliases in Git? Well, we can use the command line. So we can say git config, and we use the global switch. So you can define the aliases not only to the current repository you are working on, that's also possible, but globally, so they are applied to, and I believe this is the most common case that you want to use the aliases in all of the repositories you are working with, in all of the projects you are working with, and not just like a specific one, but that's also possible. But so we are going to define a global alias. Let's start with the CO. So check out. So we simply type a command, and now if we type git checkout, and okay, now we are not in a Git repository. So let's create a new directory, and initialize a new Git repository, so the command will actually go through. All right. So, but since we configured the alias globally, it is applied to all the Git repositories we are working with. So, but basically, okay. So we are now in a we don't have any commits and so on, but we can see that okay, both of the git co and checkout they mean the same. Okay, and the aliases are stored at least on that OS X and Linux systems. They are stored to your home directory if you have configured them globally to .git config for file. So you can either define them here in the command line with the commands, or you can also define them in the configuration file. Okay. And so we can add more aliases, such as that. Okay, if I want to do commands with the Git branch, I can use just br instead of branch. Same goes to, for example, commit. That's what we often do. So I can use, for example, that we have. So instead of writing commit, Git commit all the time, we can just write Git CI. And then we can even take it further, such as how like, for example, if we want to see what changes are in the staging area, for example, we can we don't need to type diff and cached like we would, but we can just type git dc, so which is a shorthand syntax for git diff minus cached, and the same goes on and on. I use also like git status a lot, so that we can see what's in the staging area, what's in the working copy, and so on. And another quite useful is that if we want to move information between the staging area and the working copy, we could also say that we use onStage, which we can then define reset head minus. And this actually like moving changes from the changing staging area back to the working directory. The command is actually pretty unintuitive. So actually having an alias for that, like onStage, is actually pretty nice way to go. All right. So let's try this in action then, shall we? So okay. So I'm now in the Git repository, and so I don't need to use Git status anymore. I can use Git st. And okay, and it seems I have done something horribly wrong here. Forgot probably. And then let's fix this one quickly. I forgot the equal sign here, I suppose. And yeah, okay. So now we're back in action. It always with the live recordings and so on, you miss out the essentials. Anyway, so as we can see, we can now use st instead of status and so on. But so it's much more faster and convenient now to work on the command line, since we need to basically write less. So so let's start off by editing a file. So let's add some text into the text file, and we add the files to the staging area. And yet again, we can see it here that now we can use the st, and we can also use the dc, which was the shorthand for the diff ---- catched, which shows the differences between the staging area and the working copy. So we can that's much convenient to write. We can also say git unstage and give the file there. And if we look at now, it has unstaged the changes. So move the changes from the staging area back to the working copy for this file. And so let's add the changes again, and now I'm using the shorthand syntax for the commit, and I could also pass these different. I can always pass these different arguments to the aliases commands as well, so they are working just like they would be as regular commands. Okay, and let's add something very descriptive as a commit message, and there we go. Okay, so now the next thing which would be quite nice, that okay, typically if we type git log, we see all sorts of different things, but we generally probably want to have I like the way how it shows the graph when we have more commits and branches and merges. We can see also in the terminal the graph of commits. And if we type the one line for the log, we don't see the author, but only the commit message and the first parts of the hash. So we could add a new alias to the git config, and let's say hist, and let's say log graph and one line, and this becomes now even more more convenient, that I don't need to pass these arguments around all the time. All right, but so that's really basic of the aliases that we can use, and there are of course even more complex stuff that we can do. So we can even execute shell commands with Git aliases. So there are some use cases that we could do. Here are just some couple of like very simple examples that okay, if we want to, for example, just print something to the screen with some alias. I know this has no real world like use case, but so we can define also aliases that work for shell commands, and we can do even complex stuff that accept arguments from the command line and all that to build really complex stuff with Git commands and other commands as well. But as an example, there is, for example, that if we are using Git submodules, and that's a topic that we are going to introduce in a follow-up webinar, given we get support for that, and there's like for example, that when you check out a new revision and you also want to check out the corresponding submodules, so you could, for example, define an alias for doing those two in one command. So checking out first the commit you wish from the history, and then just updating the submodules that you are using. But that's just like an example. There are myriads of examples in the web how you can, or what aliases you should or could use. But I have found that those commands that I use a lot, so basically the commit, log, diff, and this status. So if I can save a couple of strokes on the keyboard, that's just good thing. All right. Then let's move from like very of the basics to some of the things like rewriting history. So as you probably know all that in Git we typically have the whole repository, so the whole history of the repository on our local machine when we are working on it, and this allows quite nice things in general. So one of them is that we are able to rewrite the history. But then there is of course the fact that should we do it is another question, and we'll come back to that. But I will show next couple of ways how we can actually affect and rewrite the history. And the most simplest thing I would say in rewriting the history is the git commit amend, and basically what the commit amend does is that we are able to modify the last commit. And well, the typical use cases for that might be that we simply want to edit the commit message that we made a typo there, but it can be that for example we want to do actually some more changes that we want to add to that specific commit, and that we forgot, for example. Maybe there could be, for example, that we forgot to add some files to the staging area and didn't actually commit those, so we want to commit them in the same commit in order to create like a good and whole commit. But so basically using git amend is actually pretty easy. So we have our history now with just one commit, and let's continue our saga, so to say. So let's edit another file in the repository. So now there is only one file, and so we open our text editor. And let's make a typo here, for example, because I'm a lousy writer, so I make a lot of typos. Okay, I'll add the files to the repository, and I commit. And actually, I don't really like to write the CI -m, so let's actually add another alias to that as well. So so let's add that CIM. Git CIM means commit -m, and so basically then I can just write git CIM, and it will be git commit -m there. And okay, so and I'll add also a typo here to the commit message as well, so we can do both of them, both of the edits. All right, and now if we see the history, and now I'm like, oh, I screwed up really. So okay, so there is both a typo in the commit, and if we take the diff, we can also see that there is also a typo in the file. All right. So okay. So now I could of course create another commit, but I will instead just fix the changes. Okay. And and I can type git commit amend, and now if we notice that we have the hash of the commit here, and it's well, we can take it, try to remember it, but it will actually change, because we are actually changing the history in a way. So whenever we change the history, we will actually change the hashes of the commits, because they are calculated from the difference of the changes. So they are checksums. So it means that we are changing the history. But if we type git commit -- amend, we will get the same commit message that we had, and basically we can edit the commit message and remove the typo from there as well, and we save the changes. And I did now this commit command without the -m switch, so that it like opens my default editor, and I can specify the commit message there, just to show that it shows the last commit message. And okay, so now we have here the old commit, but if we type now the git hist, we can actually see that the commit has been replaced. And so basically, this is a very powerful and good tool, but never change the history of a commit that is already pushed to the shared repository. So this is a powerful tool, the commit amend, and changing the history in general. But always remember that when you are using it, use it only for those commits that are local, so only on your machine. Because after you push them to the shared repository, to the remote repository, where and you're working with other people, there will be a lot of conflicts, a lot of mix up, because the other people are basing their work on some history that has been changed. So and because of this, Deveo even prevents pushing changed history to the master branch by default. You can of course switch this, you can override this, but by default, pushing changes that would change the history in the master branch is prohibited in Deveo, because well, we believe it's a bad practice in general to change the history. I mean, to change the history is okay locally, but pushing changing the history to that kind of history that has been already shared with others is bad. Okay, but then if we move on, we'll see another way to change the history. So, and it is rebasing, and basically how rebasing works. So it works with Git branches, and it is also, even though it might not do that many practical changes, it is still a way that changes the history, because it actually creates new commits and new hashes to the commits as well. But so how the rebase works is that we have a history of Git commits here. So we have let's say 1, 2, 3 commits, and then we have started a new feature branch called experiment. And we have pushed one commit, or we have made one commit in the feature branch. But in the meantime, we have also made one commit to the master branch. Okay, and so basically, if this goes on and on, we develop our features forward and we commit often and we commit small. So at some point, when we are ready to, for example, merge our changes, we would like to actually rebase our changes in a way so that our history of the feature branch we are working with would start off from the state where the master branch is. So where we would like to end is into this kind of model, that while on the first picture we have non-linear development cycle, and sometimes this is okay depending on the workflow you're after, or if you have like very short-living changes. But if we want to kind of like get the latest changes from the master, okay, we can do also merge. But if we want to keep that commit history like linear, we can do a rebase. And okay, how we do that then? Let's go forward with that. So basically, I will check out a new branch, and let's name it the experiment as it is in the slides, and now I'm on the feature branch, and I have actually modifications in the second file, and I can just add the changes, and commit them, and say that okay, these changes are in the feature branch. Okay, and now I'm going to check out the master branch again, and here I will do some other changes, and I will add a third text file just to avoid any conflicts or all that. That's a topic for another discussion, of course. Okay. We add the third file, and remember now we are on the master branch, so this change only applies to the master branch, and we use the alias here also to commit, and okay, so now we have commits, and the branches are different. And so in the master branch we have another change and then we have in the feature branch. Okay, so now when we are developing, and we of course want to keep up with the development in the master, so we want to check that our changes, for example, work with the changes that others have put to the master. So for example, ready-made features and so on. So we simply say in the experiment branch, in the feature branch, we can say Git rebase and master, and what will happen is what is now shown in the picture. So the commit, which is now in our situation, changes in feature branch, is actually going to be moved to be started from after the committing changes in the master branch, and it's going to be it's going to change the hash of the commit, because it's recreated based on the changes. Okay, and so now if we type that the changes in master branch is replayed here, and that the change in the feature branch has been replayed here, and yeah, and the commit ID, the hash has changed also. Okay. So yeah, that's about rebasing. So it's a convenient way to kind of like keep up with that with the latest changes in the master branch, and also to, well, yeah, keep up with the master branch there. Okay. Then if we move forward, one thing we might want to do is clean up the history of our feature branch. So when we are working with feature branches, in feature branches, that especially those that are like only like your personal feature branches or branches you're working like alone, you can actually do quite a lot of stuff without caring much like how that history looks like. But the main thing is that when you actually publish the changes, whether you publish the feature branch or just like merge it or something like that, it should be in good order, and the history should be good and so on. And so for there, we can actually change the history of the feature branch, and well, of course, the other branches as well. But now we're only talking about that. Changing the history of the feature branch, because changing the history of a shared branch is not that good idea to do. But what you can do, the same command rebase offers a switch called interactive or -I, which allows you to actually clean up the different commits that are in the feature branch. So what you can do is you can just pick commits. You can squash commits or fix up the commits, meaning that you get the commits, but you don't get the commit message. Or you can drop commits altogether if you see that some of your changes are not like good enough to go live, or if you made like some mistake fixes or something like that. So you can even drop commits, and of course you can edit or reword the commit messages. So for example, if you have like some clauses written without capital cases or whatnot, you can fix those commits. And okay, let's do another experiment with that. So let's check out our master branch. And now remember that the changes that we have in the experiment branch, they are by no means merged in the master branch. So here we still have all the same changes that we have. But okay, so let's take the master branch and let's check out the new branch, like let's say like experiment 2, and then let's do couple of changes. So we have here now three files, for example. So let's add fifth file here, and add all the files, and make a commit. Fifth file added. All right. And then let's make another commit. Let's say, let's just do some garbage here. This is something we are going to then drop because we think that okay, this is not something we actually want. Okay. And then let's add the readme file and commit again some garbage, and then let's also do a couple of other files. Okay. And one more. Right. So now we have on top of this changes in the master branch, we have 1, 2, 3, 4 commits. One of them is like kind of like garbage. We probably don't want that to be included. Then maybe we want to add these together and so on. But okay, so what we can do is we can do the git rebase -I, and we give the master branch there as a reference. So the rebasing starts from the commit where the master branch is pointing, which is now in this state. Okay, and what will and I made a typo, doesn't matter, and what we'll get is the files here, and so what we can do here, like I mentioned, we can pick files. So okay, so we can pick the fifth file, that's okay, or the commit that says the fifth file added. Okay, then we can drop the garbage file. We don't want that commit, and then we can squash or fix up the seventh and the sixth file, and basically we could do so that we just fix up the seventh file into the sixth file, or actually let's squash it, because we might want to change the commit message. Okay, so basically you get the list of commits from the master, or the commit where the master is pointing, which was this, into the where our feature branch is pointing, the head of that feature branch, and we can pick, drop, pick, squash, fix up, do drop the commits, whatever, edit, reword, whatever. Okay, but for simplicity's sake, we just pick the first commit, drop the second one, pick the third one, and squash the fourth one here. And okay, and here we can now see the editor opening again, where we are actually able to edit the commit message of the two squashed commits. And I think that sixth and seventh file is an appropriate commit name there. Okay, and if we see the history now again, we have now total of 2 commits there after the rebase has been done. So pretty clever, right? So you can actually quite freely do quite a lot of things, like commit very often, because you can be very certain, and you should commit very often and very small changes, because you can be very certain that when it is time to publish those changes you are doing, that you can actually change the history, given that the changes are like only on your local machine and only on your local branch. So this gives quite a lot of flexibility, although for like it might sometimes feel a bit complex and so on the fast-paced environment. But anyway, that was like a simple ways how to alter the history. So we did the commit amendment, which was like editing the previous commit. We did basic rebasing without any like other changes to the history, except making the commits point to the other branch. And then lastly, we did the interactive rebase, which actually allows us even more power regarding what we can do with the commits. And this, especially with like long living feature branches that you might have there, this is like a very convenient way then to fix the history and the kind of like the story of your feature into like a coherent one. All right. Okay. Then we are getting back to the next topic, and which is fast context switching. And fast context switching is basically stashing changes. So sometimes when you're developing stuff like a feature and you're very concentrated on the work, but there comes an emergency that now you need to fix this or fix that, and you're working on, let's say, in one branch only. Okay, so let's say that like we are working on a new feature, and text, and so we have some changes here, like we mentioned. Okay, and basically what happens is now that our let's say project manager or whatnot comes and says that, okay, now you need to fix the documentation, the README file to contain, let's say, the names of the authors or something like that, and this needs to be done now. That you can't do anything else. You need to do it right now. And actually, well, let's. Yeah. Okay. And then, so basically, what you can do is, okay, you could go and edit the file and leave these changes to be in the on the repository. Well, now, of course, since the file that we actually added now is untracked, so it doesn't make that much sense. But anyway, let's assume that you are actually developing a feature with like real code changes and all that, so it makes more sense in that kind of context. But so okay, so what we can do is we can type git stash, and actually now, since the file is untracked, but let's actually do some more changes to the third file that we are already tracking in the repository. Because otherwise it doesn't make sense. Okay, so now we can see that we have some changes that are not staged to be committed, and we have some untracked files. Okay, so now we should do yet another edit to, let's say, the README file, for example. So what we can do is we can stash our changes, and what it does there is that it moves them from the working copy into like a stash. So and basically, if we type now the git status, so we can still see that there are the untracked files here, because we didn't specify, for example, include or untracked or git stash or all switch. But we could add like git stash all and see the status again, which means that now we actually have two stashes that we can use with git stash list. And so basically we have two different stashes that we have now put, or two changes that we have put to the stash, and we can move on to actually doing the changes that were required. Some critical changes, and we add the changes and commit. So now we have done a critical hotfix, and okay, and now we want to return back to the work. And what we do now is we simply say git stash pop, and we got the first change from the stash that we wanted. We can of course specify which of the stash we want to pop and so on. And we can see that we still have this other change in the stash. And if we do it again, now we can see that, okay, so now we have the changes back again. So I mean, we could do, of course, we could check out the new branch, make a commit there, and check out the other branch again. But you know, it's up to you to see which one is actually more useful, especially if it's like a really small change you need to do, a really small context switch that using the git stash is actually more convenient than actually like starting to check out new feature brands and thinking about how to commit stuff and so on. So, okay, but so there you have it, like very like lean way to like switch context or do some hot fixing or this kind of these kind of things. What else we can do, of course, is that we can stash the changes only partially with the stash --patch switch. This is, I'm not sure whether this is now how effective this is, but if we type git stash patch, it will now only take the changes from. Actually, we need to add some more. More changes here, and now if we type git stash patch, we can actually okay, well, the change is too small actually to be, so it needs to be actually stashed as a one hunk, but we could basically split some of the changes and only stash parts of the file and then test some other parts. So if you're thinking that some of the changes are actually causing a problem, you might use Git to actually stash some of the changes and then check that okay, will it work with only some of the changes. But anyway, the stashing is a pretty good way to help in context switching. Okay. Then if we move forward, it's actually so we can talk a little bit about different merge strategies. So of course, I will now put couple of them. So one of them is the basic regular merge. So and by regular, I would mean like a fast forward merge here. So if we are on a let's say we have now some changes. Let's just commit them and with a very good commit message. And so basically, if we have a situation where we have a branch and basically a new branch that has some changes, but then we don't, for example, have more or new changes in the master branch, we can conduct the merges in fast forward way, which means that there is no additional merge commit, but that the commits are actually just applied on top of that branch. And this is what is going to happen now. So we are going to create a new branch, which is experiment 3, and we are actually going to now do a merge like we did a couple of branches before, but we didn't actually merge them to the master. But this branch we are going to do it. Okay, so let's add a temp file and some new file with some text and okay, and so basically we have a new commit in this branch, and we check out master, and in master we don't have the same commit, but now we want to merge the changes. And if we type git merge experiment 3, so we see that Git actually says that okay, it's a fast forward merge, right? And shows the changes. And basically what we see here is that it's just the same commit. And it even have the same commit ID and all that. Okay, but sometimes we really want to have the merge as a commit. So and there if we now do the same thing, let's take another branch again, and let's edit another file here. And let's add and commit the changes. And let's check out master again. And now if we type no fast forward switch here, so no minus FF, and we do the merge, and it was experiment 4. So okay, so we actually get an explicit merge commit from this, and we can specify the commit message and all that. So this is pretty good way to ensure that we know when the merge actually happened. So that so we can see that where the changes are coming from, and when they have like derived from the master branch, for example, and when they have come back. Okay, and if we see now, we actually see that the hist alias we defined, it had the graph of option that I mentioned earlier. So we can see even in the text terminal a nice graph showing that, okay, that there's the commit, but it's the merge commit that actually has the changes. So this commit that we did in the branch does not basically belong to that, or is not in the master branch, but it's the merge commit that is there. Okay. Then to speed things up a little bit, we do another things, which is squashing the commits together, and it's basically the same as what we did there in the rebasing. So basically, let's check out a new branch, and let's put experiment 5 there. Yeah, all right. And let's do now 2 commits. So let's see. Okay, and new text file. Okay. New text file 12, and let's do another one, 13. Okay. And that's the 13 text file. So now we have 2 commits in this branch that are not part of the master. Okay, we check out the master, and then we merge with squash the changes, and actually, yeah. So now what actually happened is that we did not update the head, even though it would have been a fast forward merge like we have here. But since we mentioned that it is a squash, we will actually only get the changes here that were part of it. And what we need to do is we need to do a commit with these changes here, and this will then show that, okay, what commits are actually squashed, and we can even edit the commit message if we want, but I guess this is okay. But so basically, after the commit, so even though this change would have been a fast forward merge like regularly, if we wouldn't have specified the squash fits switch, but so now we did it without explicit commit, and if we type now the history here, so we can actually see that it's a squashed commit. It doesn't show the history or the branch that it came from. Like here we had the other branch specified, but yeah. Okay. Yeah. Then lastly, about different merging strategies. So you can actually merge multiple branches in one go as well, and that's actually pretty simple. So we can do that as one step, and then we'll go still through undoing different things very quickly. So let's check out new branch again, experiment 6, and then let's edit a new file. Okay. Okay. And let's check out master again, and let's check out the new branch from the master. So it's okay, and I think two branches is enough for us to do. And we edited now there, let's say 15.txt. Okay. And now we have one commit and one new file in both of the experiment and experiment 7 and experiment 6 branches. And if we want to merge them both at the same time, we can simply say git merge experiment 6, experiment 7, and okay. And now obviously it's something we cannot merge for one reason or another, but basically it should be possible to merge the multiple branches into the master branch, and it would create like one commit there. Okay. Okay. Anyway, I will leave this as an exercise, or we can go it through in the next webinar that we are going to host, and then still so that we still have time to go through the last thing, which is undoing different things. So okay. So some of the typical things might be that, well, basically the basic reverting of different commits. So let's say that we have the history right here, and we would want to get rid of let's say the stuff that is here. So we can use just the git revert, and what the git revert does is that it does like some like the commit, but it basically removes the changes, or does like a negative commit of that one. And so basically, if we do, for example, the revert and add the hash from this commit, for example, we can see that okay, it will revert some changes, which was the commit message, which wasn't very clear, and it says also that this reverts the commit. So it saves the hash of the commit. It's actually going to be revert, and this is actually pretty nice way that we can revert the commits, because then we have the history of the changes, that what has been reverted, and so on. Okay, but then basically the most interesting things might be that when you are doing, for example, a merge, and let's say we want to merge the experiment 6 branch here, but then okay, nice, and then if I'm now thinking that okay, so I made actually a mistake. So how can I get back to the previous point? So I can use git reset hard and type orig head, which is actually like a state that the git saves, which is the state before the merge we did. So we are now back into the into the original situation, and we can try to do the merge again, for example, or do some other changes. But so this is very good in both situations when you do a rebase and you kind of like don't actually want to do it, so you find out that it's a problem, and the same thing is for the merges. Okay. Yeah, that's about it. What we'll actually had to skip was the reflog and the Git FSCK that would help you to find like commits that you thought that were lost. But don't worry, we will have another webinar in 1st of December. And hopefully, if these webinars are popular, and we will ask some feedback from you, like what kind of topics would you like to be discussed, and in what detail level, and so on. What did you like about this webinar? We'll be sending you an email about this. But the next webinar is on 1st of December. It's going to be 1 hour. I think it's a good time for that. And so stay tuned. And from my behalf, thank you very much for coming or joining. Sorry, and if you have any feedback, do give it. Any questions? Let me know. And yeah, so yeah, from my behalf, thank you very much.